Hello everyone, and welcome to another GIS lecture video. And in this lecture video, I want to cover the idea of decimal degrees and degrees, minutes, seconds by talking about how we can convert back and forth between the two. I'm going to talk about it conceptually and then go through an example of each. So let's go ahead and just recap with the degrees, minutes, seconds, and decimal degrees. What we have is with decimal degrees, we have the whole part of the degree. And then we have some decimal portion that we went in addition. So again, in this example, right, 30.25 degrees west means we went 30 degrees west, and then we went an additional 0.25 degrees west. Alternatively, with degrees, minutes, and seconds, we can write these as fractions with increasing specificity. And I didn't explain this in the last video, but one way to think about this would be to think about it like time, where the degree is the hour, right? So in this case, we went 30 degrees, right? Minutes would be like the minutes. So how far into the next hour are we? So in this case, we are 25 minutes into the next degree. So we're 30 degrees and then 25 minutes into the next one. And then seconds would be how far into that minute are we? So in this case, right, we would be 25 seconds into that minute. And then again, the reason I use time as an example is because 1 minute is equal to 1/60th of a degree, and 1 second is equal to 1/60th of a minute, or put another way, 1/3600th of a degree. So now let's talk about how we can convert back and forth. And I think it's easiest to start by going from degrees, minutes, seconds, deg, min, sec, to decimal degrees, which I'll mark as dd, right? And so if we use d for degree, m for minute, and s for second, right, we know that 1 degree is equal to 60 minutes. And we know that 1 second is equal to 300, or 1 degree is equal to 3,600 seconds. Right, these are the two equations that I gave you from previously. These are just defined this way. And so if we wanted to go from degree, minute, second to decimal degree, what we do is we take the d plus m over 60 plus s over 3,600. It's going to give us our decimal degree. Okay? So let's look at this as an actual example. And I'm going to look at one that will be hopefully pretty straightforward, but let's just take a look. So let's say that we went 45 degrees, 30 minutes, and 40 and 36 seconds. Okay, so we have 40 degrees, 30 minutes, 36 seconds, and then we'll say that we were heading west of the equator, or sorry, west of the prime meridian. Right, so to convert this to decimal degrees, what we do is we take the 45 here, we add to that 30 over 60, and then we add to that 36 over 3,600. Right, and so what we get here is we get 45 plus 30 over 60. We can drop the zeros. That's 3 over 6, which reduces to 0.5, right? It's a half. 36 over 3,600 is going to reduce down, if we do the math on that, is going to be 0.0 0.01, right? Because this would be 1 over 100, right? If we reduce everything down, 1 over 100 is 0.01. So if we add that up, right, we get 45.51 degree. That's a very large degree sign. Degrees west. Right, so 45 degrees, 30 minutes, 36 seconds west is the same as 45.51 degrees west. So again, what we did, we took the degree, kept that whole, took the minutes divided by 60, took the seconds divided by 3600 to give us 45 plus 0.5 plus 0.01 to give us 45.51 degrees west. Okay? So that's how we convert from degrees, minutes, seconds to decimal degrees. Now, let's go from decimal degrees to deg min sec. So this is a little bit more complicated, but let's go ahead and work backwards from 45.51. So we know what we're supposed to get at the other end. Right? So the first thing that we do is we know for a fact that there is not going to be a whole number greater, so we can pull this 45 out. So we know for a fact it's 45. Then what we do is we take the 0.51 multiply it by 60. Right, because this is the portions of a degree that are left times 60. This will give us right 30.6. So we keep this 30. So we have 30 minutes. We take the 0.6, right? We multiply that by 60. And we get 36, which is the number of seconds. Right? So to recap what we did there, because this is a little bit more confusing, is let's go through this example again in a little more detail. So 45.51 degrees west. What we do is we keep the degree part whole. This is the number of degrees. So degrees, right? We don't have to do anything else with that. What we do is we take this 51.51, right? This is the decimal portion. So what we do is we figure out, okay, well, how many minutes is that? So we multiply that by 60, right? This is to recap why we're using 60 here, right? This is the number of minutes in a degree, right? So this is what's left over. This is the sort of, shall we say, decimal portion to next degree, right, times the number of minutes in a degree, right? This gives us 30.6, right? So what we have here now, right, we have this 30, right? This 30, this is the number of whole minutes. Right? So now we cut off this 0.6. Right, we do 0.6 times 60, right? This 0.6 here, right? This is the decimal portion to next minute, right? And we know that this right here is the number of seconds in a minute, right? And so if we multiply that out, right, 0.6 times 60, we get 36, which is, right, number of whole seconds. All right, and so if you look what we got, if we put this together, 45 degrees, check. 30 minutes, check. 36 seconds, check. So you can see, using this approach, we're able to go backwards from decimal degrees to degrees, minutes, seconds. And by using this approach, we're able to go from degrees, minutes, seconds to decimal degrees. Hopefully this makes sense. Hopefully where everything is coming from in these equations makes sense. And as always, if you have any questions, please reach out. Thank you.